So today I'll start with the racemization. Okay, I'll start with what is. I'll discuss. There are different way of racemization is possible. So today we'll discuss about the racemization, or maybe on Saturday we can discuss of the some of the problems. So racemization, it will take some time today, and then we'll discuss about the optical act. Some of the numericals you have seen might be they provide this kind of numericals we can also do here. So there is only first is generally racemization. I told you yesterday from one enantiomer, it is actually giving the mixture of that, right? So ultimately, we are not getting the we are getting the racemized product. That is called the racemization. So plus pure enantiomer, we are getting an optically inactive version of the enantiomer, because suppose plus A, if this is plus A, we are getting plus minus. This is optically inactive. This is optically active. This is optically active. This is optically inactive. This is there. So remember, this is called the process of racemization. We discussed this thing. Now there are different ways for racemization is possible. First one. Thermal racemization. If I tell you this is D-lactic acid, so this is then if you heat this molecule, understood what is actually happening? This portion this is becoming, this hydrogen is becoming this. If you heat this molecule, it will become enol form. From there, you can separate. If you are heating, you will be getting ultimately again. From there are two molecules can possible. Clear? So generally, this one is D-lactic acid, one is the A-lactic acid. This actually intermediate, which is actually forming, this is unstable. This is unstable. So this unstable this is D-lactic acid and this is A-lactic acid. So this is the racemic mixture. As I told you that from optically pure isomer, we are getting the enantiomer, we are getting the racemic mixture. So this is actually happened by the thermal. So it is actually thermal racemization. So this actually forming the this is forming the enol form. This enol keto to enol form is forming, which is the unstable one. Again, what can form? It can again come to, so again this hydrogen, this can again come to this, it can take hydrogen, or this is actually this, after this is becoming this. So this is, it can go from here, it can take hydrogen, or it can go like this, here it can take hydrogen. So this OH will come this side. So this is actually an example of the thermal racemization. Similarly, another example. This molecule also how it is happening? Generally, also you can write it in a different way also. I can show you. Suppose you are writing this. Means for showing like this, I showed you, but better you draw this like this. What is actually happening? See, here, thermal racemization is possible. So this molecule, this is, they are assuming that this reaction is happening like a radical way. Thermally, but radical way, the homolytic cleavage is happening. This also is possible. This is comes under thermal racemization. The best example was the first one what I showed you. Any doubt, Lakshmi, Madan and Kirti? If you have any doubt, you can clear it out. Now, second is not only thermal, you can do racemization can also happen through carbocation formation. You can get to see if you take 2-butanol. This is R, right? Clear?
Yes, sir.
Doubt? Clear, right? So 2-butanol actually from R under racemization is actually going to the S conformation. This reaction don't this I have put like a one thing of what I've done. Generally remember this. This is not a irreversible reaction. Totally all are reversible reactions. So what can happen? R will become S, S can also become R. So this is the way the racemization happens. It is actually from the optics of optically active compound is becoming racemized mixture. So this is the case for the 2-butanol in presence of a acidified condition. Very easy, not very difficult, but this kind of process happens through the carbocation formation. Even not only this in presence of a OH, H plus, is also happening in presence of a Lewis acid. In presence of a Lewis acid, it can also happen. So in presence of a Lewis acid, if I tell you Lewis acid like HbCl5, in presence of a Lewis acid, optically active alpha phenethyl chloride of optically active alpha phenethyl chloride racemizes when the compound is warmed with antimony pentachloride. I'll show you the example. If this is clear, you have noted down, then also I'll show you for the next example where the alpha phenethyl chloride molecule is actually converting into the racemized product, but through the carbocation formation, but in presence of a Lewis acid. In case of a only acid we are using, but another example I will tell you where they are using and they are actually acting as a Lewis acid. sorry, phenethyl I have written, na? It should be methyl. 1, 2 carbon, alpha position, chloride, phenethyl, yes, phenethyl, okay, fine, no problem. This is the one. 2 carbon, alpha phenethyl chloride. This is the one. If you heat, this is antimony pentachloride. So this is also an example of the racemization through carbocation formation. Okay, this is easy. Now I'll show you racemization through carbon ion formation. Or here you can say exudal ketone, na, DB. Acha, what is the IUPAC name of this compound if I draw it? So tell me what is the IUPAC name of this compound? This is the phenyl butyl ketone. What is the IUPAC name of this compound? Anyone? What about Lakshmi? Can you tell? This is the very easy question, not very difficult. Madan, don't be silent. Can you tell? Kirti,
So,
tell me what will be the name? Just I thought of a randomly should have been phenyl butyl ketone, but what is the IUPAC name of this particular compound? Can't? See, one phenyl, two methyl, butan, one one or butanone. To start from C double bond because that is the pH group is there. So that is the way you should know, should write. One phenyl, two methyl, butanone. Generally, this kind of molecule racemizes in presence of a base. Generally, the NaOH in ethanol or something they provide in presence of a base in ethanol. Suppose if I provide this molecule, one phenyl, two methyl, butan, four carbon on. Remember this. This molecule undergoes racemization in presence of a base. Suppose sodium hydroxide in ethanol, you provide what is this is a chiral carbon. The chiral carbon is actually, if it is R, it will be, I have not showed in R and S way. you can understand by seeing that it can be R, it can be S. If you provide anything, so it will become again it will just change because of the formation of the keto-enol tautomerism. Here in between the formation of carbanion is happening, that carbanion is actually undergoing a keto-enol tautomerism. This keto-enol tautomerism, again, it is actually taking the proton and ultimately it is actually, if it is R, it is becoming S, if it is becoming S, it is again converted into R. This way the racemization happens. So generally, what is the criteria they have? Generally, remember this, the criteria is that they must have an acidic proton. See, this is C double bond O. That means this is H. So this OH minus is taking hydrogen. That means this is the acidic proton because it is there in presence of a C double bond O. Like you remember this aldol condensation wherever it happens to the acidic condensation. If that is the case, you should always remember this that this is actually happening. So this is the case, racemization is happening. So you should have a acidic proton. You should have a acidic proton. Okay, now I'll discuss about tell me, I'll give another example. Tell me whether it is actually the same thing will happen or not. That is your thing. If this is the case, okay, you tell me racemization will happen or not. This is the question. Give me 1 minute. I'm coming back. First, you decide. You tell me. Three of you think of and let me know whether they are actually having. They will be having the decimalization is happening. Give me 1 minute. I'm coming back. What is the answer? Can this molecule undergo decimalization or no?
It will undergo also.
It will undergo. Acha, what about mother? You tell me. Lakshmi, what do you think? I'm just wanted to know what are you thinking. That then only I can tell you, na. Then only I can understand you that where.
Undergo.
Tell me, please.
It will undergo, sir.
It will undergo. Acha, mother, what is your from your answer? I want three answers. Na, you always vote, three people always vote at the same.
Don't know, sir.
Don't know, means you're neutral. Okay, no problem. So two people are saying it will happen. Actually, it will not happen. Why? See, it should have here. Where is the chiral carbon? Tell me. Where is the C double bond though? This is not that acid. So OH minus will not take, this is the beta. Aldol condensation happens where? Only the alpha position. Remember this? So this molecule will in case of OH minus, it will be take little bit it will take up, but not racemization will happen. This beta hydrogen is not acidic in nature. So this is only alpha. So if there is no process of racemization, there is no way this will become R2 or S. Understood? So remember this. What is the criteria to check? That it should have any kind of electronegative thing or any electron withdrawing group should be nearer to the exactly attached to the carbon, which is the actually the chiral one. This is the process of racemization in presence of a carbon atom. So this molecule will not undergo racemization.